Hello students, let us continue the session on rational numbers. In previous session we had solved exercise 1.1 till question 8. Now the ninth question. Is 0.3 the multiplicative inverse of 3 1 by 3 why or why not? Let me write this 3 1 by 3 in a improper fraction. This becomes 10 upon 3. If I express this 0.3 in p by q form, this will be 3 upon 10. On multiplying this 10 upon 3 with 3 upon 10, I get the product as 1. Therefore, 0.3 is the multiplicative inverse of 3 1 by 3. Question number 10. Write first one, the rational number that does not have a reciprocal. The rational number that doesn't have a reciprocal is 0 because 0 is same as 0 by 1. The reciprocal of 0 is 1 by 0, which is not defined. For the first one, the rational number that doesn't have a reciprocal is 0 because 1 by 0 is not defined. Second question, the rational number that are equal to their reciprocal. The rational numbers that are equal to their reciprocal, they are 1 and minus 1. The reason is the reciprocal of 1 is 1 only. The reciprocal of minus 1, let me mention here, reciprocal of 1 is 1 by 1. Reciprocal of minus 1 is 1 by minus 1, which is same as minus 1. So the number and their reciprocal, they are equal to each other. Question 3. The rational number that is equal to its negative is 0. The rational number that is equal to its negative is 0. Reason is the negative of 0 is minus 0, which is same as 0, because we have learned that 0 is neither negative nor positive. When we consider minus 0, it is same as 0. Question 11 is to fill in the blanks. First one, 0 has dash reciprocal. It has got no reciprocal because 1 by 0 is not defined. The numbers dash and dash are their own reciprocals. The numbers 1 and minus 1, they are same as their reciprocal, one's reciprocal. The third one, reciprocal of minus 5 is negative 1 upon 5. The reciprocal of 1 by x, where x is not equal to 0, is x. The product of two rational numbers is always a rational number, because we have learned the same thing in closure property. The reciprocal of a positive rational number is positive always. This is the last question of the exercise. Now we shall take up exercise 1.2. The first question of the exercise is to represent the numbers on the number line. Here 7 by 4 and negative 5 by 6 are the numbers given. Roughly I'll be drawing a line and I'll be representing it. You can do it properly on your notebook. What we require to do to represent 7 by 4 is we need to have a number line such that the consecutive numbers are made into 4 equal parts. Suppose if I consider the number line, if somewhere here is 0, I'll make 4 equal parts between 0 and 1. So the first part here is 1 by 4, the second part is 2 by 4, the third is 3 by 4, and the fourth part itself is 1. Likewise, we'll continue. This next part will be 5 by 4, next is 6 by 4, next is 7 by 4, next is 8 by 4, which is same as 2. So this particular point, let me mention this point as A. A represents 7 upon 4 on number line. I can mention the line as L. Same procedure to be followed for the second one also. Negative 5 by 6. Between the consecutive numbers, I'll make 6 equal parts. That is, I'll start in a reverse direction. Let me write this line as L. Suppose if here is 0, the next is negative 1 upon 6, next is negative 2 upon 6, negative 3 upon 6, negative 4 upon 6, negative 5 upon 6, and this one is negative 1. So between the two consecutive integers 0 and minus 1, I have made 6 equal parts, of which the fifth part represents the given rational numbers. So B represents the number negative 5 by 6 on number line M. So remember friends, I have not taken all the integers on the number line. I have just considered the two integers which are closer to the given rational number. Question 2 is also related to the number line. Observe here the numbers given, they have the denominator 11. It means that 11 parts are to be made between the consecutive integers. Since they are all negative and all the values they lie between 0 and minus 1. So when I consider the number line, start with 0 at this corner, next is minus 1 by 11, minus 2 by 11, minus 3 by 11, minus 4 by 11, minus 5 by 11, minus 6 by 11, minus 7 by 11, minus 12 by 11, minus 6 minus 7, this is minus 8, minus 9 by 11, minus 10 by 11, minus 11 by 11 is same as negative 1. So observe here, this point P represents negative 2 by 11, point Q represents negative 5 by 11, point R represents negative 9 by 11. This is how we can represent the given rational numbers on the number line. I urge you to do it with proper scale, use proper ruler. The distance between the consecutive divisions here are to be same. Preferably, if you take the distance as 1 centimeter, you require 11 centimeter line on which 11 parts are made, and the ends are represented with 0 and negative 1. Question 3. Write 5 rational numbers which are smaller than 2. I can write the number 2 as 20 upon 10. Let 2 is written as 20 upon 10. Hence, the number 1 by 10 is smaller than 20 by 10. 2 by 10 is smaller than 20 by 10. 5 by 10 is smaller than 20 by 10. 10 by 10 is also smaller than 20 by 10. Then I can consider, say, 15 by 10 also smaller than 20 by 10. 19 by 10 is also smaller compared to 20 by 10. All these are smaller than 2 or 20 by 10. This is how logically can be solved. Question 4. Find 10 rational numbers between negative 2 by 5 and 1 by 10. Since the denominators are different, let us make their denominators same. So let me find out the LCM of the denominators 5 and 2, which is 10. So negative 2 by 5 is same as negative 2 multiplied to 2 by 5 multiplied to 2, which is negative 4 by 10. 1 by 2 is same as 1 multiplied to 5 upon 2 multiplied to 5, which is 5 by 10. Can we find 10 rational numbers between these two numbers? It's not possible because negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, they add up to few numbers. So what I do is, negative 4 by 10, I will multiply this with, say, 10 and divide by 10. I'll get minus 40 by 10, minus 40 by 100. The same way, the 5 by 10, when I multiply by 10 by 10, I get 50 upon 100. Now I can write so many numbers between these two numbers. That is, negative 40 by 100 is smaller compared to negative 39 by 100, negative 38 by 100, negative 37 by 100, negative 36 by 100, negative 35 by 100, negative 34 by 100, so on till positive 49 by 100, less than 50 by 100. This number negative 4 upon 100 is same as negative 2 by 5, and this number is same as 1 upon 2. So not only 10, we have written more than 10. Here I have multiplied each one of them by 10. If you can multiply by 5 also, we get more than 10 rational numbers between these two numbers. Logically, when the multiple of 10 is multiplied, it becomes easy for us to collect the numbers and write. Question number 5. Find 5 rational numbers between 2 by 3 and 4 by 5. Let me make the denominators as the same. So let me take the LCM of 3 and 5, and it is 15. So the given number 2 by 3 is same as 2 multiplied to 5 upon 3 multiplied to 5, which is 10 by 15, and 4 by 5, which is equal to 4 into 3 upon 5 into 3, this is 12 by 15. Now there's only one rational number which is easy to guess between 10 by 15 and 12 by 15. So what we can do is, since they have asked to write 5 rational numbers, let me multiply this particular numerator and denominator with 6. If I multiply with a 6, I'll be getting 60 upon 90. At the same time, if I multiply 12 by 15, the both numerator and denominator by 6, I'll be getting 72 upon 90. So clearly, we have 60 upon 90 smaller compared to 72 upon 90. So 60 by 90 less than 61 by 90 less than 62 by 90 less than 63 by 90 less than 64 by 90 less than 65 by 90 less than 66 by 90 less than 67 by 90. Likewise, it is less than 72 by 90. So here 1, 2, 3, 4, 5, and more than 5 I have written. It's easy now. One more method is, after finding the LCM, I can guess some number. Say, if I convert both the denominators as, say, 60, so 2 by 3, I can multiply and divide by 20 so that it becomes 40 by 16. This 4 by 5 I will multiply by 12 by 12, which is 48 by 16. Now between these two I have 41 by 60, 42 by 60, 43 by 60, 44 by 60. Like this also we can find the rational numbers between two rational numbers. The next question is to find 5 rationals between negative 3 by 2 and positive 5 by 3. Let me write this particular number with the denominator as 6, so that I'll multiply by 3, I'll be getting negative 9 by 6. Similarly, this 5 by 3 I'll multiply and divide by 2, so that the denominator becomes equal to 6. Now between these two numbers I have negative 9 by 6 less than negative 8 by 6 less than negative 7 by 6 less than negative 6 by 6 less than 0 less than 1 by 6 less than 2 by 6, and I can continue till less than 10 by 6. So more than 5 numbers we have found between the given rational numbers. One more question. For this question I'll tell you another method, an alternate method. The alternate method is, if A and B are rationals, then A plus B upon 2 is between them. I'll use this method. I'll find out the first rational number between 1 by 4 and 1 by 2 is 1 by 2 times of 1 by 4 plus 1 by 2. The LCM of 1 by 4 and 1 by 2 is 4. So 1 plus 2, we get it as 3 by 8. Now I'll find out the second rational between 3 by 8 and 1 by 4. So that is half of 3 by 8 plus 1 by 4. LCM will be 8. So when 8 is the LCM, the 3 should be added with 2. We get 5 by 16. The third rational I'm going to find between the 3 by 8 and 1 by 2. That will be half of 3 by 8 plus 1 by 2. The LCM is 8. When 8 is the LCM, we have to have 3 plus 4, which is 7 by 16. Now I am going to find the fourth rational between 5 by 16 and 1 by 4. That is half of 5 by 16 plus 1 by 4. The LCM is 16. So 5 to be added to 4, we get 9 upon 32. The fifth rational I am going to find between 7 by 16 and 1 by 2. So half of 7 by 16 plus 1 by 2. The LCM again is 16. When 16 is the LCM, 7 to be added with 8, we get 15 upon 32. So I have found 5 rationals between 1 by 4 and 1 by 2. Question number 6. Write 5 rational numbers greater than -2. This -2 can be written as -20 upon 10. So now it's easy to identify 5 rationals greater than -20 by 10. 5 rationals greater than -2 or -20 by 10 are, I can consider -10 by 10, -5 by 10, -1 by 10, +5 by 10, +7 by 10. So these are few. Question 7, this is the last question of the exercise. Find 10 rational numbers between 3 by 5 and 3 by 4. Let me write this 3 by 5 as well as 3 by 4 with a common denominator. For that, let me multiply both the numerator and denominator of these two rationals with some number. Say if I multiply this with 16 and the second one with a 20, I'll be getting 80 in the denominator, and the numerators are 48 and 60 respectively. Therefore, we have 48 by 80 smaller compared to 60 by 80. So I have 48 by 80 less than 49 by 80 less than 50 by 80 less than 51 by 80 less than 52 by 80 less than 53 by 80 less than 54 by 80 less than 55 by 80 less than 56 by 80 less than 57 by 80 less than 58 by 80 less than 59 by 80, which is less than 60 by 80. These two numbers, 48 by 80 is same as 3 by 5 and 60 by 80 is same as 3 by 4. So between them I have found 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers between them. With this discussion, I'll end today's session. In the next session, we shall take up the questions from NCERT exemplar. That's all for today's session. Thank you.